I am continuing my video series on moderators and interaction. You may recall from the first video in the series that I illustrated interaction using a hypothetical example in which we looked at the relationship of the amount of love that couples have to the number of walks that they take in the park. I'm going to go ahead and look at that example again. These are hypothetical data, but we're going to look at it in a lot more detail as we illustrate an example of interaction, and even more specifically, an example of moderation. So the park data has three variables in it. The number of times a couple is observed walking in the park in 1 week is called park walk. The temperature on the day of the observation, and that's in degrees Fahrenheit, that is the temperature. And then an index to quantify the degree to which the dating couple is in love, and that variable is called love in the data set. So let me go ahead and call up my R notebook, and I'm going to go ahead and read in these data. So let me go ahead and clear out my environment here so we can start from scratch, clear out my console, and let's read in the data. And here it is. There's 20 observations of the three variables as I just described them. And the first thing I'm going to do, since my response variable is park walk, that is the number of walks taken, and my explanatory variable is love, is I'm going to create a scatter plot. Let me go ahead and do this all from scratch, and so I'm going to go ahead and clear the output, and we'll start from scratch here. So here's a scatter plot that relates love to the number of walks, or vice versa, the number of walks as a response to love. And you can see that it's a fairly strong relationship, and it looks like a line would be a reasonable representation of this model. I don't see any curvilinear relationships here. And then the other explanatory variable that we're using is temperature. So let's go ahead and look at that as well. And again, I see, doesn't look like as strong of relationship, but it still looks like there is a relationship. And again, probably about the best model that I could fit through these data would be a linear model in the form of a line. So we have what we want in terms of our two explanatory variables being linearly related to our response variable, number of walks in the park. Okay, our primary interest is in determining whether temperature moderates the effect of love on walks in the park. So let's look at a picture of what we're doing here. So we have the number of walks as our response variable. And then we have our primary explanatory variable is the amount of love that we have. So we're wanting to see if the amount of love will influence the number of walks in the park. But temperature, we're now wanting to create a model in which we see if temperature moderates the relationship of love to the number of walks. So that's a special case of interaction, and I could diagram it this way. That is, temperature is going to influence the relationship of love to number of walks. As the temperature varies, then the influence that's represented by this line here between love and number of walks, that will be influenced by temperature. Now, if I want to be technically correct, I also probably need to draw an arrow here from temperature to number of walks. Why? because we leave in lower order variables whenever we look at interaction. That is, all of the individual variables that are involved in the interaction are also included in our model. So really the model of interest to us is this one, but we are allowing for the possibility that temperature also has a more direct effect on the number of walks, as well as moderating the influence of love and the number of walks. Okay, so back to our notebook. Here I've created a model, a linear model, in which I'm looking at love, temperature, and now here's the cross product, love by temperature. And let's go ahead and look at that model. And what I see in that model is that love and temperature, in fact, has a very small p statistic, indicating to me that the estimate of 0.02 relative to its standard error is quite high. So that relative estimate to variability of the estimate is quite high, and therefore this is fairly reliable. This would indeed be something we would expect to see, some interaction that we would expect to see even if we were to take additional samples, or even if we had access to the entire population of lovers and looked at their walks in the park. So we also notice, you may also notice, oh, what about this? There's some instability here. Remember that when we have interaction, we are going to focus on that. And that is our primary interest. That is our interest. It's not on these other variables. So we treat them very much the same way that we treat the intercept when we're doing a single variable model or a multiple regression model. What do we do about intercept? Well, we don't say much about it, we don't focus on it, and we don't even worry about when the p-value is high. It still is establishing a baseline for us, and so we have it in the model. In a similar sense, the inclusion of love and temperature establishes a baseline, and then our interaction is relative to that baseline, because what interaction is showing us is an effect that occurs above and beyond the effects of love and temperature. So I'm not worried about the fact that I have high p-values for love and temperature. They're just establishing a baseline for me. I'm not going to try to interpret those individually. Why not? Because I have interaction. And therefore, how much love influences walks in the park depends. What does it depend on? It depends upon the temperature. I also note that my model is very strong with a multiple R squared of about 0.89. 89% of the variation in the walks in the park can be accounted for by this model, and I have a very small p-value, which is not surprising given the strength of our model here. So looking at this is as our coefficients and our model, but our primary coefficient of interest is this one. Our primary p statistic is this one. But what I wanted to also show you, this is an R fact more than it is a statistical fact. And this is not just in R. This would be true if you were working in SAS, SPSS, or pretty much any statistical package. We can use shorthand. And the shorthand is this. Let's create a linear model in which we're looking at the number of couples walking in the park as a function of this interaction. Well, remember that I've mentioned to you before, and just mentioned again, that we want to have a baseline that includes love and temperature as well as the intercept. And so you might ask, well, shouldn't that be in there? The reason we can do this shorthand is because they are in there. The intercept, love, temperature, it's all in there. Why? because these packages, these statistical programs recognize that you are almost always, the exceptions for not including temperature and love would be rare and get into some complexities that are beyond the scope of what we're going to do here. You almost always are going to include them. And so the default is when you put in interaction, it's going to put in everything lower than interaction, everything that's at a lower level. And that would include love and temperature, which lower to that even is then the intercept. So all three of those things are included. This is just like when we create a variable model in which we don't have interaction, we don't have to specify the intercept. It's always included automatically. So now let's dig into this interaction. Particularly, we want to see it as a moderator and how much it is moderating. Let's look at the picture. This is familiar to you in terms of the coding. If you watched the previous video, I did the same sort of thing where I basically am taking the four coefficients. The first one's intercept. The second one is for love by itself. The third one is for temperature by itself. And the fourth one's the interaction. And I'm selecting a couple variables or a couple points for the temperature variable that I know are within the range of the model. If I look at, in my console window, if I look at the minimum of park temperature, it's going to be 28. And if I look at the maximum of park temperature, it's going to be 82. So I picked a couple values that are far apart from each other, so if there is interaction to be detected, I can see it, but also still within the range of the data. So here I have plugged in 35 degrees everywhere temperature occurs in my model, and here I've plugged in 75 degrees everywhere that temperature occurs in my model down here. So if we go back up here and look at this model, and let me go ahead and call up my little notebook again. So if we were to write down the model, we would have about 2.0 for the intercept. So our response variable is number of walks. Let's just write it as our y hat in a general format. And we would have 2.0 for the intercept. I have minus 0.18 times love. I have minus 0.03 times temperature. And then I have plus 0.02 times the interaction of love and temperature. So if you look at this particular model here, all we're doing is substituting in first 35 degrees and then 75 degrees for temperature. So let's take the example of 35 degrees. So we're putting that in there. And then let's take the example of 35 degrees again. We're still doing the same thing, times 35 there. So that's why you see this in our notebook where I put in 35 here to match up with what we did here in this model. Okay, and then I went ahead and did a little plot. I already pre-tested and created my limits for my x-axis and for my y-axis, so it would come out and use the entire range and look nice. Here's the 35-degree plot and then a 75-degree line that's superimposed on it. And then I'll talk about this text here in a moment, but let's go ahead and look at the plot. So there we see the interaction. So first thing is, let's make sure we can interpret what we're seeing in terms of interaction. Is love related to number of walks? You look at this picture, the answer is yes. As love increases, so does the number of walks in the park. How much is it related? Answer, it depends. So therefore we have an interaction. It depends. And this supports the model that we drew earlier, this model that we drew back here, that temperature is moderating the influence of love. So as when it's 35 degrees, the effect of love is not as pronounced in terms of the number of walks in the park. Note the slope is not as great as when it is 75 degrees, then love in fact will lead to substantially number of walks as the love index increases. I said I would mention this text command in R. So what I've done here is put the middle of that 75 degrees, this little string here of 75 degrees that I have in quotes, I put the middle of it, 5 along the horizontal axis right here, and 9 on the vertical axis right there. And I will tell you that when I use this text command, often I end up putting it first and then fine-tuning it by adjusting those later. So the fact it's coming out all nice and looking in the right place here is because behind the scenes, I tested it before making this video. So there's no shame in trying it and having it go right on the top of the line and saying, oh, I need to adjust, and then you adjust it. Okay, let's see what the slope is here when the temperature is 35 degrees, because remember that our effect is interpreted in terms of the slope. How much change in there is in y for every unit change in x. In this case, how much change in the number of walks for every change in the love index. And so what I've done here is the exact same thing in terms of this equation that we were looking at before. Exact same thing, except now I'm actually going to put in values for love as well. And so back to my R notebook, I'm putting in an index of 5 for love right here and an index of 6 for love here. Now you might ask why 5 and 6. It doesn't matter. It doesn't matter where you are along the x-axis, just I'm looking at a 1 unit change. So how much does a 1 unit change, 5 to 6, and why doesn't it matter? Because the slope is the same no matter where you are along the x-axis. So what does a 1 unit change do to the change in the response variable, the number of walks? So what I'm doing here is taking my outcome, my predicted values for 6 minus for 5, and that will show me how much there is a change for y, the number of walks. That's the slope. So the slope here is about a half. So that would say that for about every 2 unit increase in love, we get 1 more walk. And if you kind of eyeball it here from 6 to 8, you're down here in terms of number of walks at about 4. And then by the time you get to 8, you're maybe at about 5. And so 2 units is about 1 additional walk. Let's do the same thing for 75 degrees. That's what I'm going to do here. And now I get 1 point, about 1 1/3. So if we were to do a 3 unit increase, that would be 4 additional walks. Now, obviously, it'd be nice to compare those. So if you think about here, we did a 2 unit increase, here we did a 3 unit increase. Well, those would both divide evenly into 6. So what I did here is times each of those by 6, so we could do a comparison. For every 6 unit increase, you get about 3 more walks here when it's 35 degrees and about 8 more walks when it's 75 degrees. So that higher influence of love on the number of walks at 75 degrees is why we have an interaction, because at 35 degrees, it's lower. Now, if you think about the things that could happen here, we could have ended up having 35 degrees be a flat line, which would have meant that love has no effect on number of walks for 35 degrees, and then 75 degrees have a slope. So there's various ways that it can occur. It can even happen sometimes that one of them will go down while the other one goes up. That's also an interaction. The only time it's not an interaction is like what we saw when we were looking in a previous video of the effect of brain size on IQ, and we saw that height, in fact, made a difference by itself, but it did not interact with brain size, so we got parallel lines. Parallel lines would indicate no interaction. The further away you are from parallel, the stronger the interaction that there is. Okay, that's it for love and walking in the park. And I think in the next video, I'm ready to start creating a report that involves the potential for interaction.